Hi everybody, my chemistry friends. This is Mrs. Ewald signing in, and we're going to go ahead through solubility, specifically solubility curves. So what I want to show you first, hopefully you have your handout with you. Take that out now so that way you could follow through with me. Solubility curves, the curve never changes. So this here is the curve that you're going to always get. Just like your periodic table, it's always the same. And so what you really need to first understand is what the solubility curve tells you. And then we're going to go from that into calculations that we can do using the solubility curve. Now, I want to give you a warning. Please make sure that you listen to my whole podcast without skipping or fast forwarding, because I really want to make sure that you understand how to complete these calculations. A lot of people start off strong, think they know it, but then bomb on it on their test because they don't fully understand what it means. So please make sure you stick with me, okay? We'll try to do this fast, but make sure you listen to all of it. So what I have here is a cheat sheet. I came up with the best way of trying to go through a procedure so you can methodically go through each problem and make sure you did it right each time. So the first big rule of thumb, if you answer a question without having to look at the solubility curve, you are doing it wrong. So many people go through, set up proportions, and they don't even look at the curve. Then you know you should have a red flag in your head. I'm doing this wrong. Stop, stop, stop. Beware. Okay? So looking at the curve, on the x-axis, it has temperature in degrees Celsius. On the y, it's grams of solute per 100 grams of water. So I'm going to rewrite it. Grams of solute per 100 grams of water. Now the first thing to understand, make sure you understand what solute means. Now you might remember this from biology, but just a refresher, remember the solute is what you dissolve. So that's a substance you dissolve into something, and that something is the solvent. Okay? So this is what is the medium by which you're dissolving the solute. And so what you're looking at here are all of the salts that are your solute. So potassium iodide, sodium nitrate, potassium nitrate, these are all solutes that are dissolved. And the solvent in this case is water. Okay? And so we're looking at aqueous solutions. We remember that from when we did balancing equations. Remember AQ means aqueous. So looking again, it tells you the temperature and it tells you how much of a solute is dissolved in 100 grams of water. Now, the curves themselves. So if you look specifically at a curve, okay, anything that falls on the line means that it is saturated at that point. So this would be a vocab term. What this means is that it is completely saturated with that solute in 100 grams of water at that temperature. If you go above the line and it's not on the curve, that means at that temperature it would be super saturated, meaning that you have more solute than you do needed to saturate the solution, so some of it will come out of the solution. Anything below the line is unsaturated. What this means is that you don't have as much solute as needed to fully saturate the solution. Okay? Think of it like Kool-Aid or iced tea is a good example. With iced tea, you want to add sugar to it to give it a little bit more flavor. So with the right amount, just the perfect amount of sugar, you have a saturated solution of iced tea. Those people like to keep adding packet after packet after packet, it's going to give you a super saturated. And those that only like a little bit, or you really hardly taste it, that would be unsaturated. Okay? So let's go through these steps. Now, I would follow these steps each time, especially in the beginning of when you do a solubility curve problem. Okay, so what we're going to do is really get into the meat potatoes now. Knowing what this curve means, again, it's with 100 grams of water. It tells you how much is saturated at different temperatures. Okay, so the curve tells you how much is dissolved in 100 grams of water, so make sure you note that. Anytime you see it out of a different amount of water, we may have to set up a proportion, and I'll show you that in a moment. The first step should always be to look at the temperature. So if there is a temperature provided, you want to look at the temperature first and then follow where the salt is, what curve it is you're looking at. Remember, when I say salt, I'm referring to these ionic compounds, okay? Or in this case, covalent here. The first step, okay, looking at temperature, and then find out how much is saturated, the number that falls on the line in 100 grams of water, as we mentioned here. You can then use a proportion to solve for how much solute can be dissolved in a different volume of solvent at the same temperature. So again, you want to make sure you look at your table, find out how much is dissolved in 100 grams before you move on at that temperature. And if you are solving for the temperature, then you will need to set up a proportion first and then work backwards. And that's what we're going to do in our first example. So we're going to look at these examples, use them as a guide while you're working on your handouts in class. So make sure everybody has this filled out, show all of your work, show all of your units, and you're going to use this in class while you're doing your solubility curve handout. So the first question, and we're going to need the curve in the picture here. So what is the minimum temperature needed? So we're solving for temperature. So we're going to have to do things backwards here. Needed to dissolve 100 grams of potassium chloride. Identify your salt. Potassium chloride, that's KCl. Ooh, I guess you're going to have to remember your naming and writing formulas, right? And 200 grams of water. So here it says, we needed to, what is the temperature needed to dissolve 100 grams of potassium chloride in 200 grams of water? That is our given. So because we're not giving temperature, we can't look at the curve first here. We're going to use this given. So 100 grams of potassium chloride in 200 grams of water. So this is what we're starting with. It's not saying it's saturated at this point. It's saying this is what we have. So we have 100 grams of potassium chloride dissolved in 200 grams of water. We don't know if it's saturated, supersaturated, unsaturated at this point. But we want to know what the temperature would be to get it to be saturated. So I'm going to want to set up a proportion and find out, well, how much of that potassium chloride would I need to dissolve in 100 grams of water, and then I'm going to use that to look onto my solubility curve to see what temperature that would be. So you set up a proportion, and you're going to cross multiply. So 100 times 100 divided by 200. So your x will equal 50. Now that means 50 grams of potassium chloride will be saturated, or 50 grams of potassium chloride in 100 grams of water. So now what I'm going to do is look at potassium chloride on my curve, which is right here, and I'm going to find when there's 50 grams dissolved in 100 grams of water, right around here, and that is about 80 degrees Celsius. That is when I will have a saturated solution of potassium chloride. Voila! Easy, right? But make sure you understand how I solve that. Next question. If 170 grams of ammonia are mixed with 200 grams of water at 15 degrees Celsius, how much will not dissolve? Different problem, right? Now I'm giving you a temperature to look at first. So we're looking at ammonia, so that is NH3. I'm going to look at my curve, and I'm going to look at 15 degrees. So ammonia at 15. That's about 60. We all agree? So at 15 degrees Celsius, we know based on our curve that 60 grams of ammonia will be saturated in 100 grams of water. I'm using my temperature, looking at it directly on my curve first, and finding how much is saturated in 100. Now, It says, though, that if 170 grams of ammonia are mixed with 200 grams of water. Well, let's see, based on this information here, how much would be saturated then in 200. So now I'm setting up my proportion. So 60 times 200 divided by 100 will give me 120 grams of ammonia divided by 200 grams of ammonia. And so divide that out, right? Okay, so what this means is that 120 grams of ammonia is saturated in 200 grams of water. However, we are given 170, so how much will not dissolve? So I'm going to take this value and subtract it from 170. So this means 50 grams of ammonia will not dissolve. Done. And that would be my answer. I'm just going to circle it in. All right, last question. If 30 grams of potassium chloride are added to 200 grams of water at 30, temperature, red flag, we're going to look at our graph first, and we're going to find out for potassium chloride, so we're looking again at KCl, how much is saturated at 30 degrees Celsius. So KCl, where are we at? At 30. Hem and haw. We'll say about 35. Keep it easy. So 35 grams of potassium chloride is saturated in 100 grams of water. But we have 200 grams here. So how much would be in 200 then? Cross multiply, 35 times 200 divided by 100. So that would be 70 grams of potassium chloride would be saturated in 200 grams of water. But we only have 30, so how much more must be added? You would have to take then 70 minus 30, so 40 grams of potassium chloride need to be added. Done. So I just took you through 3 different types of problems you could do with solubility curves. The first one, remember, is when you're having to solve for temperature, so you do a proportion first. The other 2 are when you're given a temperature, so you use your graph first, and then you do a proportion. So make sure you keep that straight. All right? This is Mrs. Ewald signing out, saying happy solubility curve, and practice. Make sure you have it with you. Peace out.